All right, let's go over the answers to Exam 2, Form Y. Question number 1, find the derivative and do not simplify. So for the first one, it's a simple power rule. So bring the 5 down. 20 times 4 is 5 times 4 is 20. X to the 4th power minus 3 times 4 is 12. And then times x to the 3rd power. 9 times 2 is 18 times x, and the derivative of 12 is 0. Part B, we can't do this one quite yet. We need to rewrite it algebraically. So the 7th root of x to the 11th becomes x to the 11 over 7 power. The square root one, since we know its derivative, we can leave it the same way here. So the derivative is going to be, bring the 11 sevenths down, times x, and then lower the power by 1. Remember the trick that we had. We take 11 minus 7, and that gets you 4, and then leave the denominator the same. So the power is 4 over 7, and the derivative of the square root function is 1 over 2 square roots of x. Question C, find the derivative of y equals x to the 4th plus 5x squared, all that times e to the x. So we need to use the product rule. So it's the derivative of the first times the second unchanged plus the derivative of the second. The derivative of e to the x is just e to the x times the first unchanged. Question D, find the derivative. This is a quotient rule. So it's the derivative of the top times the bottom unchanged minus the derivative of the bottom times the top unchanged divided by the bottom squared. Question E, find the derivative. So the derivative of e to something is e to that something, but then you have to multiply by the derivative of the exponent by the chain rule. So that's 18x squared. F, find the derivative of y equals natural log of 12x squared. So it would be y prime is equal to 1 over the argument of the log. So that's 12x squared times the derivative of the inside, and that's 24x. G, find the derivative. So this is your basic exponential and basic log rules. So for the derivative of the exponent, it's the base raised to the x times the natural log of the base, so 5 to the x times the natural log of 5, plus, and now the derivative of log base 5 of x, so that's 1 over x times the natural log of the base, and it's the natural log of 5. All right, question H. Find the derivative of 8x to the 4th plus 5x squared minus 1, all raised to the 9th power. So that's a power rule, but it's got a chain rule part to it. So we bring the 9 down. The inside stays the same. Lower the power by 1, and then multiply by the derivative of the inside. I, find the derivative of y equals 7 times the square root of 3x plus 8. The 7 on the outside is multiplying being multiplied by the square root. Since it's a multiplier, it stays. If it had been added or subtracted, then it would have a derivative of 0. But as a multiplier, it just stays right where it is. So we start with the 7. Then we're going to multiply by the derivative of the square root. So it's going to be 1 over 2 square roots of, and then the inside stays the same here, 3x plus 8, but then we multiply by the derivative of the inside. The derivative of that inside is 3. That's the answer. And finally, for j, we have y is equal to the square root of the natural log of x squared plus 1. So this is a double chain rule. So we're going to have y prime is equal to the derivative of the outermost function. The outermost function is the square root function. So that's 1 over 2 square roots of, and then everything that was inside the square root. Natural log of x squared plus 1. Now, the next inside function is natural log of x squared plus 1. So the derivative of that is a natural log. So it's 1 over the inside of the natural log, x squared plus 1. But the inside of that was not trivial, and so we take the derivative of that. And the derivative of x squared plus 1 is 2x. So there's your double chain rule. Okay, let's look at problem 2. Find the equation of the line tangent to f of x is equal to x squared plus 2x minus 3 at the point where x is equal to 4. So we need two parts. We need the slope, and that's going to be found by taking the derivative at x equals 4. And we need the point, which is 4 comma f of 4, the original function evaluated at 4. So let's start with the slope. The derivative is 2x plus 2, and the slope at 4 is 2 times 4 plus 2 is equal to 10. To find the y-coordinate of the point, we evaluate at 4 in the original function. And what is that? 16 and 8 minus 3, so that's 21. So the point is 4 comma 21. And now we use y equals mx plus b. The y-coordinate is 21. The m is the slope is 10. The x is 4. And then we have the b. So 21 is equal to 40 plus b. So that means b is equal to negative 19. So together, using the slope and the y-intercept, we get y is equal to 10x minus 19. Let's look at problem 3. Let f of x equal x squared plus 5x. Find delta y and dy for when x is equal to 0 and delta x is equal to 0.2. So let's recall the formula for delta y. That's f of x plus delta x minus f of x. And so let's do that one first. So x is 0, delta x is 0.2. X is 0 again. So this is f of 0.2 minus f of 0. Now we have to plug in 0.2 into the function. So it's going to be 0.2 squared plus 5 times 0.2 minus 0 squared plus 5 times 0. 0.2 squared is 0.04. 5 times 0.2 is just 1. And then these numbers over here are 0. So the answer is 1.04. Next, we want to find dy, that's the differential. So it's f prime of x dx. So we need the derivative. So let me write the function up here again. So the function was x squared plus 5x. So that derivative is 2x plus 5 times dx. Remember that delta x was 0.2, and when we work with differentials, we assume that the delta x and the dx are the same. So we have 2 times our chosen x value. The fixed x value was 0, plus 5 times 0.2. Well, that's just 5 times 0.2 again, and that's just 1. And notice how close these two values are. They're supposed to be. Example, problem number 4. The total sales in millions of dollars t months from now are given by S of t is equal to t cubed plus t squared plus 2t plus 1. Find the rate of change in total sales after 2 months. So if we want a rate of change, we need a derivative. So it's going to be 3t squared plus 2t plus 2. And we evaluate at 2 months. Plug in 2. And we get 12 plus 4 plus 2 is 18. And so that means the rate of change is $18 million per month. Problem 5, find the slope of the tangent line to the curve 4x squared minus xy squared minus 14 at the point 2, 1. So we need to find this derivative using implicit differentiation. So there's the equation. I'll differentiate the first part. The derivative of 4x squared is 8x minus, and now the derivative of xy squared is the product rule. This seemed to be the problem that tripped a lot of people up. You have to recognize this as a product, and you can leave the negative on the outside. So it's the derivative of x is 1 times y squared unchanged, no derivative of the y because it wasn't the derivative of y, it was the derivative of the x part here, plus now the derivative of y squared, which is 2y y prime, times the x unchanged. And of course the derivative of 14 is 0. Now the negative has to distribute. Rewrite this a little bit, like that. And we're going to solve for y prime. So I have two terms that do not have y prime in them. So I move those two terms to the right side. Now divide by the coefficient. The coefficient is negative 2xy. And finally, to find the slope of the tangent line, we evaluate at the given point. So 2, negative 1. And we plug in 2 for x. And 1 for y. And when you work that out, you get 15 over 4. Question 6. The total cost in hundreds of dollars for producing X copiers per week is given by C of X is equal to 3 plus 40 times the square root of 5x plus 4. Find the marginal cost when producing 12 copiers per week and interpret. So marginal cost is found by taking the derivative of the cost function. The derivative of 3 is 0. The derivative of 40 times the square root of 5x plus 4. 40 is a constant multiplier. It stays. And we have 1 over 2 times the square root of 5x plus 4 times the derivative of the inside of 5. You simplify that. 40 divided by 2 is 20. 20 times 5 is 100. So this should be 100 over the square root of 5x plus 4. Now find that value when x is 12. We're going to plug in 12 for x. So it's 100 over the square root of 5 times 12 plus 4. 5 times 12 is 60, plus 4 is 64. Square root of 64 is 8, and then 100 divided by 8 is 12.5. Or you could have left it as a reduced form, 25 over 2. So what that means, because this was in hundreds of dollars, then that means the marginal cost is $1,250 per copier. And the interpretation is at a production level of 12 copiers per week, cost is increasing at a rate of $1,250 per copier. Let's look at the solutions to exam 2Y, the calculator portion. Question 1, Bob invested $4,000 in an account that earns 2.8% compounded monthly for 5 years. How much is in Bob's account after the 5 years, and how much interest did he earn? So we'll use this formula. The principal, 4,000 times 1 plus 0.028 divided by, how frequently was it compounded? Monthly, so that's 12 raised to the 12 times 5. If you work that out, you get $4,600.34. And the interest is that number minus 4,000, so just the $600.34. Part B, Bob also invested $8,000 compounded continuously at 1.75%. After some time, the account grew to a total of $10,000. Write the equation to solve for the amount of time it takes to grow to $10,000 and then solve. So this was the PERT formula. So it would be 10,000 is equal to 8,000 E raised to the interest rate 0.0175 T. So that's the equation to solve for. Now to solve it, we divide both sides by 8,000. And that's going to be 1.25. Yeah. E to the 0.0175 T. Since the variable is in the exponent, we take the natural log of both sides. And that gives me the natural log of 1.25 is equal to 0.0175 T, and T is equal to the natural log of 1.25 divided by 0.0175. You work that out and you get 12.75 years. Question 2. Suppose that the daily demand X for lattes at P dollars per latte is given by X is equal to 600 minus P cubed. If the price is increased from $4.50 to $4.60 per latte, use differentials to calculate the approximate change in demand. So first, what will the differential formula be? We have x is equal to 600 minus p cubed. We need a differential formula that's going to be dx is equal to, and then the derivative, which is x prime of p, because x is now a function of p, the price, times the differential of the price. So what was the differential in the price? Well, the price rose from $4.50 to $4.60. So that would be $0.10 or 10 cents. Now remember that we assume the delta P to be equal to the dP under the differentials assumption. And we need the derivative of the x function. So the derivative of 600 is 0. The derivative of negative p cubed is negative 3p squared. The p is the basis price that the action started at. That's $4.50. And then times the 0.10. And if you work that out, you get negative 6.08, which is lattes per dollar. So basically what it says, well, we don't even need the per dollar part in this case. We've already done the ratio part. So what this says is, if you increase the price by 10 cents, then you're going to have a drop in the demand for your lattes by 6. Six less lattes will be sold. Question 3. The price-demand function for selling computer mouses is known to vary linearly, with a weekly demand of 250 mouses. The company sets the price at $16. And with a weekly demand of 300 mouses, the company sets a price at $12 per mouse. Find the price-demand function by expressing P as a function of X. So X is the demand, it's the number of mouses, and P is the price. So these ordered pairs are in the form of X comma P. We're looking for a linear equation, because it said it was linear, in the form of P is equal to mx plus b. And so we'll do this this is just regular algebra, right? So m is equal to 16 minus 12 over 250 minus 300. So that's 4 over negative 50, which is negative 0.08. Next we need to find the b. So I'll just pick one of these points. I'll pick the second one. So the price of $12, the slope of negative 0.08 times 300 mouses plus b. So that's 12 is equal to negative 24 plus b. And so b is equal to 36. So using the slope and the y-intercept, we get p is equal to negative 0.08x plus 36. So that's the linear equation that gives us the price-demand function. We also need to find the domain. So to find the domain, we're going to, running out of space here, we're going to set p equal to 0. Well, let's just set it equal to 0. And you get 450. So that turns out to be the maximum number of mouses that you can sell. And so the domain, put it over here, goes from 0 to 450. Question B. Find the revenue function for producing X mouses and its domain. So revenue of X is equal to the number of items times the price demand function. So that would be X times negative 0.08X plus 36, which is negative 0.08X squared plus 36X. And then the domain is the same. The domain of the revenue function is inherited from the price demand function. Find r prime of 300 and interpret. So we'll take the derivative. So r prime of x is equal to negative 0.16x plus 36. Evaluate at 300. So plug in 300. And that's negative 12. And the interpretation is at a production level of 300 mouses, revenue is decreasing at a rate of $12 per mouse. Let's look at problem 4. The total cost and total revenue in dollars for the production and sale of high-definition TVs are given, respectively, by C of x is equal to 70,000 plus 200x, and R of x is equal to 1,000x minus x squared for x between 0 and 1,000. Find the profit function. So profit is equal to revenue minus cost. Now you got to be sure and distribute the negative correctly on this. That was a big problem on the grading. There should be parentheses right here for the cost function, because the negative has to distribute to here and here. So this is going to be negative x squared plus 800x minus 70,000. Find the break-even points. So the break-even points are when p of x is equal to 0. So negative x squared plus 800x minus 70,000 is equal to 0. I'm going to multiply every term by negative 1. That changes the sign of all terms. And then I'm going to factor. What two numbers multiply to give you 70,000 and add to give you 800, 700, and 100? And so the break-even points are x equal 100 and 700. Find the average profit function. So p bar of x is equal to p of x over x. And so that's negative x squared plus 800x minus 70,000 over x. And you could have left it that way, that's fine. Because I know we're going to do a marginal analysis here in a second, I'm going to go ahead and divide x into each portion. And now marginal, so p bar prime of x is the derivative of this equation. So that's negative 1. Derivative of 800 is 0. And if you work with these long enough, you'll get the pattern when you do the derivative of something over x. It's the same number, opposite sign with x squared. Question E. Evaluate the marginal average profit function at a production level of 200 TVs and interpret. So P bar prime of 200 is equal to -1 plus 70,000 divided by 200 squared, which is 0.75. And here we go again. At a production level of 200 TVs, average profit is increasing at a rate of $0.75 per TV.